Hey everyone, can you hear me? See some thumbs up. Let's go ahead and get my laptop switched on. There it is. I'm gonna put this in my pocket, hope it stays on. So far so good. Awesome. So a little bit about me. My name is Nick, and I'm an engineering manager here at DigitalOcean on our storage team. I'm very funny, as you can see, my coworkers agree. Is still working on the improvement, but also a software thought leader. No software bugs in my department, none in the block store at all. It's evidenced by my coworkers once again, so you're in good hands tonight, don't worry. So I'm going to be doing Block Store 101, which is a dive into what block storage is, some use cases, a little bit of the technology behind it, and just kind of give an introduction about how it works. So to start off, what is block storage? In an analogy, it's a thumb drive in the cloud. So think of it like another piece, just like your droplet, but sitting around, floating around in the cloud somewhere that you can plug into one droplet, unplug and plug it into another droplet at any time. It is right now local to a single droplet. And the way block storage works is it's low-level raw blocks of data being read and written from your droplet. Kind of like a USB drive for your virtual machine. You're meant to run a file system on top of it, so ext4, XFS, or something like that. So it's very low level. And it fundamentally abstracts a ton of disks and a ton of servers and kind of creates one meta disk for your virtual machine that you can read and write data from. So think of it like a super scalable bunch of servers sitting around running some software that all funnels up to your individual droplet. It's replicated for integrity and availability. So every time you write a piece of data that's sent to multiple drives and multiple servers, so that if one of those servers goes down, one of those drives goes bad, which happens way more often than I would like, it's fine, and you'll never notice. And it's movable from droplet to droplet. So if you've got a VM running a web application or something like that, and you want to size up, you want to move it over, deploy a new operating system, a couple API calls or a few clicks, and you can have that storage attached to another VM. So it's super flexible that way, in that it's kind of removes some of the storage from needing to be tied to your droplet and lets you have that extra flexibility. And you can size it up at will. So if you've got backups or media or something, and you're saying, wow, I filled up this 500 gigabytes. If only I had 500 gigabytes more, I have good news for you. In one click and in less than 30 seconds, that volume has doubled in size. And you can keep on doing that all the way up to 16 terabytes right now with just a click of a button. So super, super powerful tool to kind of add on to the droplet there. From another perspective, what is block storage not? Block storage is not object storage. So object storage is like your Amazon S3, right? I've got a file or a piece of data. I want to put it somewhere and be able to fetch it over HTTP, have a global identifier. That's not block storage. Block storage is local to your VM, and block storage is used for storing stuff on that droplet, for retrieval on that droplet, or if you move it to another one on the other droplet. It's also not a file store. So it's not like NFS, it's not like CIFS, where what you're doing is reading and writing from a bunch of different machines to one hard drive or one system. It's designed for one-to-one pairings because it's so low level and so designed for file systems on top and stuff like that. Object Store may be coming soon to DigitalOcean at some point, something we're working on, just to give you a little hint into that roadmap that Julia was talking about. So how does block storage work? I probably could sit here for an hour or two and chat about it. I don't think we have enough alcohol or enough food. So I'm going to do a little bit of an abbreviated walkthrough. I told you I'm funny. So the really powerful thing about it is that each one of your volumes actually lives on many servers. So every time you write a block, there's a really powerful algorithm in the back end that actually chooses a drive on a server in a rack somewhere to put that block. And this happens thousands, hundreds of thousands, millions of times a second for a bunch of people, so that you can kind of address an entire data center with just your droplet as far as storage goes, which is really cool. And that means that when one of those drives or one of those data nodes goes down, because it's replicated, there's another one in the data center, and transparently to you, you get to use it. So if your block of data is on 3 different drives and 3 different servers, and the network's down, someone tripped over the cable, lightning, fire, cosmic rays, the server's down, that's fine. And then another drive fails somehow or something like that, that's still fine. Your data is still very much alive and kicking, and you can still access it like nothing ever happened, completely transparently to you in your VM for your services, your websites, and your applications and stuff like that. There's a lot that goes into that algorithm. We call it a pseudo-random distributed block placement. So every time your VM asks to write a piece of data, it kind of randomly goes across and says, what are all of the places I could do this? Picks one. And then that means your droplet kind of has a map. So it can look at this data center, pull this map apart, and go, like a big, giant filing cabinet. I'm going to open this drawer, toss this in and close it, and then I know where I can get it when I want it. But that, again, that happens millions of times a second, lots and lots of filing cabinets. And when things change, when servers go down or when we add more servers, that map's updated on the fly on your droplet. You don't have to worry about it at all. It just works. And then how, what, why, where, and when. What do you want to use it for? Why would you want to use it? There are a million different use cases. I did a word cloud because we're a cloud hosting company. Funny, I know. But these are just some of the many things you can do. You can run databases on top of it. Databases you can size up. If you get strike it rich, get super successful, and with a click of a button, you've doubled the size of your database. Use it for backing stuff up. Since it's replicated 3 times, you say, I've got this really important customer data. If my droplet goes away, I'd really rather not lose it. You can just copy it over on the block storage and know that it'll stay there. And a bunch of other things. And there's some competitor stuff in there. We pulled this from a list of customer suggestions and stuff like that. But yeah, that's block storage. Simply put, it's expandable storage to attach to your droplet that you can use for whatever you want, just like the droplet product. Much less expensive, much more scalable, and I may be biased because I've been working on it for a while, but much more fun. Thanks. I know Julia said only 2 people actually have a surprise remote guest, one of the engineers who worked on the block storage project. So I'm going to go over to a Hangout and see if I can dial him up and get the sound working and stuff like that. So bear with me for a sec. I'm going to go ahead and refresh this. We're a remote company, by the way, so this is par for the course. So is Hangouts not working every now and then. So we'll see.
Hey, can you hear me?
That's right. Round of applause for Antoine. You ready? All right, we've got a video to play. Settle in.
My name is Antoine Grondin. I'm a software engineer for DigitalOcean, and I work on the storage team where...
Hello, everybody. Antoine was supposed to give a demo. Unfortunately, Antoine was not mindful of robot feelings. So something happened. Anyway, I'm giving the demo. Hello, everybody. We're going to create droplets that have volumes attached to them. Let's look at my account. Yay, we're logged in. Let's create a 100 GB volume in NYC1. There, the volume is created. We can now make a droplet that will have that volume attached on boot. Nice. Now we need to do something while the droplet is creating. Let's talk about the meaning of life. Law. So, what if robots were conscious? Would they have rights? How many days have you lived? How many days are left? Is it enough for all you want to do? Robots don't die. Robots have all the time in the world. What would a robot have to say to prove that it's conscious? Do you think we should have AI governments? Do you think AIs would build a wall with Mexico? Sorry, I'm just filling the void while our droplet's creating, so our droplet is up and has a volume attached to it. Let's SSH into it. We're in. Let's look at that volume. Sweet, 100 gigabytes. Let's make an ext4 partition. And mount it. Let's go in there. Yay, so many gigabytes. Let's send a very important file to our droplet. Law. Ugh. Never. Gonna. Give. You. Up. Alright, enough with this. Die droplet, die. Oops, in a sudden excess of robot rage, we deleted a droplet with our important file on it. We didn't want to lose this file equals. But oh, we can just create a new one using the same volume, and here we are again, contemplating the passing of time. What makes you believe that everything around you really exists? Just kidding. Well, that droplet ain't gonna create itself. What if you were in a computer simulation? Could you know? If you are then in a simulation, what's the difference between you and me? There, we're ready to carry on. We're in. Let's mount our volume again. Let's go in there. Hopefully everything is still there. Yup, looks like it. Tum-tum, 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 tum-tum. Never. Gonna. Give. You. Up. Never gonna give you up. So here's what we saw. I created a droplet with my 100 gigabyte volume attached to it. I destroyed my droplet by mistake. On purpose. Yes, of course. Despite that purposeful destruction, I didn't lose my data. After creating a new droplet with the same volume, I was back in my Rickrolling game. That's it. I'd like to thank DigitalOcean and my mother for making all this possible. Let's clean up our droplet. And our volume. Yay, what a great demo. Remember to be respectful of robots. Or else.
I'm sorry, Dave. I'm afraid I can't do that.
So that was great. I'm gonna get this set up. My name is Ben Schechter. I'm a product manager here. I've been working on the Droplet team for the last the last 8 months or so. And recently have also been helping out on block storage. Actually, maybe before I even get started here, well, a little bit more about me. I used to be an engineer, transitioned into product management, so kind of fit this world between being technical but also trying to explore what developers are trying to do. So before I dive into, I think we've kind of taken a look at what block storage is. We've seen how we can do things through the API, and I'm going to be kind of going through what's done on the control panel. DigitalOcean makes things very simple for developers through a web-based UI that other cloud infrastructure providers don't necessarily do. So we take a look at things from an API experience, but we also put a lot of work into how can you seamlessly manage your infrastructure through something as simple as a website. But I kind of wanted to just start off. So how many people in this room, just raise your hand if you've fired up a droplet on DigitalOcean or have done anything with DigitalOcean? Okay, cool. Keep your hands raised if you've done something with our block storage offering already. Sort of. Sick. Okay, cool. What are you guys doing with our block storage offering? Just set it up. Okay.
I just backed it up, put some files on there, drop it a little bit, and shut it down.
Backed it up, put some files on there. There was someone over here who had used it as well? No? Feeling shy? Maybe I just saw a hand? No? Okay. Cool. So I came up with just like a demo of what you could do with block storage in the event that you were working on some sort of website, right? Or some sort of social offering. And so I'm just gonna run through things here. Let's just make sure this is recording. Did we do the recording of it? Yeah, cool, he's got me. So can you guys see this? Or should I make this a little larger font? So if you haven't seen, so actually maybe we'll do the inverse. There were so many people that raised their hands, had done stuff on DigitalOcean. Raise your hand if you haven't fired up a droplet on DigitalOcean. Okay, we'll get there. We'll get there soon. We're gonna get you, yeah. So what I'm gonna do is I'm gonna start a website, a social networking website for, let's pick something that has a tremendous amount of potential users. Something that'll start small, maybe scale up slightly. So I'm gonna start a social networking website for ants, insects, not like your in-law type, or not in-law, but family member, whatever. So this is, if you haven't seen it, I apologize if this is redundant for you who have done DigitalOcean related things before, but you can come in here, you can select a distribution, you can select a size, doing something as cheap as $5 a month and scale all the way up. We're not gonna attach block storage right now, and let's just put it in NYC1. Get my SSH key added, and we'll just flip on private networking for fun, and we'll call it my awesome ant website. Sounds good, right? Cool, so we'll let that droplet build, just as we saw on the API. Just like developing this website, don't need a ton of storage. I have a really easy way of just what do we have here? 40 gigs. 40 gigs, so I'll start up a database. Let's just work with the example of having a database, right? I would love to have a database that goes larger than 40 gigabytes, but right now I'm just getting started. I'm just kind of I just released it to the ants, and there's just a couple first time adoption people getting started with it. But let's say this starts blowing up. Maybe it's getting out there to a bunch of different people, or excuse me, insects. And my database gets so big that maybe I want to put it on a block storage volume, because as we saw with what Nick and Antoine discussed, it's a very seamless, scalable solution that's actually going to be cheaper, right? So, I'm paying $1 per gig for local storage, but I'm paying 10 cents per gig per month for block storage. So my ant website is blowing up. I'm going to just start off with, actually, let's do 50 gigs. We can customize whatever we want here. So we can make it as small as a gigabyte. We have some pre-selection options for you if you want to choose one of those, but let's just call this my ant volume, and we'll create that volume. The nice thing that happens here is all those things that you saw through the API, we just kind of give you the directions here just really easily. So I'm gonna just show you on the VM that, not doing gem install stuff, but let's get into this droplet. So we're on the droplet now, and we'll just really quickly do a little bit of, let's go ahead and format it and mount the volume and LSB. Okay, great. So we've got our local disk now. Let's just pretend I am, I've done the work of putting it onto this volume, my database on this volume, and now I can scale up to N more ants out there. So great, this is awesome, and it's all represented through a really easy to use control panel and everything like that. So let's say that things are really blowing up. This is like the new Snapchat or new Instagram thing since they just launched that as well. They're all cannibalizing each other. We'll jump in on that. And let's go ahead and resize our volume. So you can do this really seamlessly through the UI as well. Let's just say we want to go up to 800 gigs and resize it there. DigitalOcean will just kind of give you the progress bar. Boom, done. Let's just make sure that this is represented on our droplet. You can see here, it's gone from 50 gigs and is now 800 gigs. We can scale up a ton and do whatever we need to do. So it's kind of nice, right? Like, we've put a lot of effort and thought into not only how you can do these things through an API, which is how a lot of you may be interacting with DigitalOcean, but if you are kind of doing things through the control panel, we want to make sure that's very seamless as well. The other thing that Nick had discussed is transferring volumes between droplets. So let's go ahead and see what that would look like. So, you know, we have a huge database. It's like, it's really like blowing up. We've got the database side of things down. Maybe we should create another droplet so we can serve those front-end requests just in a more efficient manner. I think it's worth going through this. Let's go ahead and just detach my database from, let's pretend I put a landing page up on that website. You know, everything's powered down. I don't have to worry about consistency issues. We're good. I'll go ahead and detach it here. Let's create another droplet while that event kind of fires off here. And let's go up to like, I don't know, let's go a little crazy. It might take a little bit more time for this to go. We'll do NYC1, put on my SSH key, way better, and server. Create. We'll let that fire off. While that's going, you can see here, in addition to droplets, you can view what volumes you have. You can see this one's currently unattached. It's just kind of hanging out, waiting for us to do something. We can go back and check out the request here. That's going to take a little longer. We can get out of this VM for a second. Great. What? Am I doing this right? Live demos, right? There we go. Okay, we're in this server, or this droplet, excuse me. Let's check out the volumes. Let's attach this volume. Instead of doing a new one, let's go to our unattached volumes, go ahead and attach this. We won't reformat it, that would be a little rough. And we'll just do this, LSVLK. And there is our database over to this new server and everything like that. So that's just kind of like a walkthrough of some of the things that you can do. I kind of showed initially, you know, you might start, I kind of wanted to like take a developer's approach to what you might encounter. So, you know, we see people kind of creating things on a single droplet. Then very quickly, one of our biggest requests is how do we, you know, have a scalable storage solution so that I don't need to pay more money because we don't really need more compute or more RAM. We just need storage just kind of on its own. And we've provided that in what we think is to be a pretty cost-effective manner. So yeah, I can answer any questions. I can do more of this kind of stuff. If there's any questions about block storage generally, about what Nick talked about, he's over here. Does anyone have any thoughts? Yeah, what's up?
What's the backend response guarantee? Is it ZFS, RAID 5?
Nick, come on up here. These are questions so all engineering questions I'm going to direct to Nick, and all product behavior, all that kind of stuff, I'm going to, yeah, I can talk through that kind of stuff. Yeah.
Can you use this as a DR solution, so, like a HA solution between two nodes, so that let's say you set this up as shared storage between two separate nodes, and then fill over one node to the other?
You can. So a volume cannot currently be attached to multiple droplets at the same time. So I think like in terms of high ability, an offering might be like better suited in terms of, it depends on kind of what your behavior that you're looking for. Yeah, go for it.
Let's say I have a database on node 1 and it fills over to node 2, but the storage is attached to node 1.
So that could be accomplished in the same kind of demo that I showed there. Like in the event that something catastrophic happens.
Storage can be zoned to both nodes at the same time.
It cannot at the same time, no.
Not currently.
Not, yeah.
Just one-to-one right now.
Do you want to re-ask your question, actually? Yeah, go for it.
What's the backend supporting? Was it RAID 5? What's
So it's backed by a software-defined storage system. So it's multiple servers, not using NFS or any other protocol, using a storage driver in QEMU to communicate with that giant kind of software storage array. So there's no RAID involved. It's like a kind of proprietary protocol that communicates with the backend.
so kernel basically?
Yeah, well, the QEMU driver has storage plugins that communicates with all those servers and the software running on them.
So what are the performance characteristics relative? What are the performance characteristics relative to the local storage?
So it's, with replicated remote storage, you'll get a little bit more latency. You'll get a little bit more latency, but at a trade-off of much more consistent performance, and a little bit less, fewer IOPS and a little bit fewer megabytes per second. But it should be consistent everywhere, whereas local storage, noisy neighbors and stuff like that can be a little more variance.
Great presentation. Great presentation, guys. Thank you. So can it like resizes itself, like after what you did manually? Can it be done like automatically?
So to resize the volume requires an API call or something in the control panel right now. There's no reason you couldn't add some sort of monitoring component to your server to make that call automatically. But because we don't have a window inside of your droplet, there's no way for us to know how much space you're actually using down to the granularity that you get when you SSH in, kind of a security thing.
Great presentation. Just a bit of a two-parter. Are the stores able to migrate across region? And can you clone a particular store and just basically another store with the exact same?
Yeah, totally. I'll answer the second one first. Cloning is very much on the roadmap. That's the next feature we're going to get out, kind of snapshot backup and then create from snapshot backup. So look for that one pretty soon. I don't have any exact timelines, but soon. And cross-region migration is also coming later, but that's definitely something we want to do. It won't be kind of active replication, so it'll be an asynchronous transfer process, but that's definitely something we're looking into.
The current regions where block storage is supported is right now NYC1, SFO2, and then maybe I should say the actual New York City 1, San Francisco 2, and Frankfurt just launched is like on Monday. Wow, Monday. It's been, lots of stuff.
So in your presentation, you had a slide with S3 and EBS and saying replace it. I didn't understand what was the point. Does it replace S3, does it replace EBS, or does it not?
So it's designed, works a similar function as EBS. So it's a block EBS, Amazon EBS, the block storage. You can run an application on top of the block storage to function like Amazon S3. I believe MinIO, MINIO.io is pretty popular for that, but it's designed as a lower level block storage replacement similar to EBS.
Okay, another question. The demo with the robot, you killed the volume, and then you reinitialize it, or you resurrect it. Is that my understanding of it correctly? Like you deleted something by mistake, and but what about what if someone wants to actually delete it? I mean, or would that be, or am I still being charged for it?
Yes, so there's two different resources that were in that demo. There's the droplet that the volume is attached to, and then the volume. So in the demo, the droplet was destroyed, but the volume was attached to. And that leaves the volume sitting around. So that leaves just the volume and not the droplet. And then we created a new droplet with that volume attached. So they're separate resources.
It's like the VM versus the actual block storage volume. So, right? It was the first.
Floating IPs, for example, if you attach a floating IP to a droplet and you destroy the droplet, the floating IP stays around to be attached to a second droplet.
Okay, thank you.
I think we have, Oh.
Is there a way to convert the root FS for one of my droplets to block storage, or to use block storage as the root file system?
So it could be done. probably shouldn't say this as a hack right now, but as only having block storage for a droplet is also something we're investigating but haven't done quite yet. SSD storage is suitable for backup storage because it's lower latency and stuff like that. It's something that we'd like to do, definitely. Although if you really got down in there and you mess with your bootloader a little bit and stuff like that, it could totally be done. Once again, probably shouldn't go into that.
There's no multi-pathing support?
And what do you mean by that?
Multi-pathing meaning multiple paths to one run?
Yeah, I mean, so that's that's some iSCSI terminology. So it's not backed by iSCSI, but similar ideas, right? You're in direct communication. The backend is in direct communication with multiple drives and multiple servers, but not exactly multipathing to individual ones. No. I'm happy to chat more afterwards if you want to understand how it works.
So I'm asking this question out of curiosity. I've always wondered, NYC 1, 2, and 3, what are the differences? Do you launch anything on one first? And I feel like that's an internal thing that you guys talk about a lot, but I'm kind of curious.
So yeah, I can answer that. So they're basically different data centers. So yeah, so a data center within New York City, it's basically a space where we have some services there already versus not. So block storage, we want to roll out to every single data center. The first one that we rolled it out in is NYC 1. So if you want to use block storage, you have to choose one of the 3 supported data centers right now for it, but we're working on rolling it out to all additional data centers. Does that help or not?
Yeah.
Okay.
I'm kind of curious, because would you roll out to one first? Like if you wanted the latest and greatest, you could get
I see. I see. I will say that the offerings between data centers are typically we try and keep them as in sync as possible. So there's no massive gain or loss with creating a VM in one versus another. It's actually more of just a budgeting thing from our perspective. So we make an investment in the hardware that we need to deploy to all of these data centers, and we want to do that in a way that we think we can learn initially for what we need to provision in the future, in the same way that we do hardware provisioning for the Droplet experience. So those were kind of our 3 initial ones to start, and we'll definitely be sharing more in the future for where the next regions will be, but the hope is that we'll get it everywhere as quickly as possible.
Thank you. In your demo, you created the second droplet as a public one, and the first one as a private one, and there was no warning between, when you switch the storage. So wouldn't that be like a good thing to have? Like if you switch storage from a private droplet to a public droplet,
I think this was, so are you referring to the checkbox that yeah, I think I just have been conditioned to select private networking, which just attaches a private IP network interface to that droplet, and I think I just forgot to do it for the second one. So both of those droplets were technically public. Having private networking versus not is not dependent for having block storage available to that droplet. So that was just me fudging around on the yeah.
So currently the block storage can only be used.
When it's attached to a droplet, or can you expose it like IP of some sort to use it from anywhere?
Currently, you can only use the data stored on a volume as accessible through a VM. So you need to have a droplet, which is standard. I'd be curious to know what the use case you were thinking of maybe, because it may be better suited for something like an object store if you're trying to serve files externally, which that is kind of usually built into an object storage type offering. But with block storage as it exists right now, we're really, the use case is essentially that it's used in conjunction with a droplet or VM. Cool, thank you everyone for coming.